The first learning target has you factor all sorts of things here. The first question has x squared minus 8x equals negative 15. So we're going to start this by putting the 15 onto the left side of the equation by adding 15 to both sides. And the point of doing this is that it's going to put it in what we call standard form. It's where everything's on one side, the x squared term's in front, the x term in the middle, and then the regular number coming after it. And 0 is going to be on the right-hand side. So this is in standard form now, and we can proceed with the rest of the factoring process. I don't see a GCF, so I'm going to multiply my a times c values. The a value here is equal to 1, because there's sort of an invisible 1 in front of your x. The b value is negative 8, and the c value is 15. A times c is 1 times 15, giving us 15. We've got to find the two factors of that also add up to negative 8. I'm going to choose negative 3 and negative 5 because they together add up to negative 8, and they also multiply to make 15. I'm going to take a moment here to rewrite the original equation considering this split. The original equation had been x squared minus 8x plus 15, but we're going to rewrite it x squared minus 3x minus 5x. That's based on the split of last step, plus 15. It's worth noting that negative 3x minus 5x is actually the same thing as the negative 8x from above. It's just sort of broken apart in a very specific way. Then we're going to draw a 2 by 2 box, and inside of that 2 by 2 box, we'll put all those terms from the last step. I'll go back to purple. We have x squared, negative 3x, negative 5x, and 15. And we've got to find the GCFs of everything, every row and column. The GCF at the top is just x because that's the only thing they have in common between x squared and negative 3x. Negative 5 will be the GCF of the bottom row because 15 is also divisible by 5. And you're noticing there's a negative 5 as the first thing we encounter to the right of our negative 5 GCF spot. And because the first thing we view as negative will make the GCF negative as well. Same reason you're going to actually have a negative 3 right here. And 3, by the way, because 15 can divide by 3 really cleanly, equals 5. These are your two factors, x minus 3 and x minus 5. You grab those GCFs from the top and from the left. You do the same process in the second question. You have a value of 1, b value of negative 1, c value of negative 30. I'm not going to show the whole process over again. The answer to this problem was x minus 6 and x plus 5. The way you do it is exactly like the last problem, but I'm not going to spend the time to do that right now. We have two more factoring questions, actually, and these two factoring questions here are a lot easier than the last two examples because they're actually special cases. You'll notice on the left side, 9x squared minus 36x has no c value, like it's plus 0 or something like that. But it has no c value, and you'll notice that every single term there has an x in it. What that means is we can simply factor a GCF out of those two terms. They share a 9 as part of the GCF because 36 is divisible by 9. We know 9 is going to be part of that GCF. And both terms have an x. So the GCF must include x, 9x. And what's left over after pulling it out is x minus 4. And you're done. That's it. The next question is actually similarly easy because both of the terms are perfect squares. We're going to square root both of those terms to create one of the factors, x minus 6. And instantly, because we had this so-called difference of two squares format, which is perfect square x squared, a minus sign in the middle, hence difference of two squares, and 36, also a perfect square for 6. Square root each of them, make a factor, and then instantly the other factor has the same numbers but a plus sign instead. And that's instantly and automatically factored, no harm done. So those are your 4 factoring examples from the test.